Welcome to Resource Creation 2 assignment. Myself Girish Bhide from Phenolics Academy, Ratnagiri, hereby present my video on global coefficient matrix and example. These are the contents: important formulae, determination of element coefficient matrix using Microsoft Excel, how to find global coefficient matrix, and summary. In FEM, usually triangular elements are preferred, and hence we must calculate area of triangle, for which this formula is easy to remember. It reads A is equal to 1/2 of x1 y2 minus x1 y3 plus x2 y3 minus x2 y1 plus x3 y1 minus x3 y2. Now, the shape functions alpha 1, alpha 2 and alpha 3 are required in order to derive the formula for general term of an element coefficient matrix. The general term is Cij of E, given as integration of gradient of alpha I dot product with gradient of alpha j ds. If we take an example of C12 of E, then we have C12 of E is equal to integration of gradient of alpha 1 dot with gradient of alpha 2 ds, and hence we have C12 of E is equal to 1 upon 4a into the bracket y2 minus y3 into y3 minus y1 plus x3 minus x2 into x1 minus x3. Similarly, we can find all the remaining 8 terms from the element coefficient matrix, which consists of total 9 terms, that is 3 by 3 size. Let us go to an Excel file showing calculations of such matrices. Here we are. This sketch consists of 3 elements, and the coordinates of the vertices are also given in this sketch. Now, using these coordinates of vertices, we can find out the element coefficient matrices for these 3 elements as shown over here. So the formulae required for computation of C11 in context with the PPT slides are also mentioned over here. So C11 is given as 1 upon 4a into the bracket y2 minus y3 bracket square plus x3 minus x2 bracket square. C12 is 1 upon 4a into the bracket y2 minus y3 into y3 minus y1 plus x3 minus x2 into x1 minus x3, while C22 is 1 upon 4a into the bracket y3 minus y1 bracket square plus x1 minus x3 bracket square. Now, the element C13 can be computed very easily from the property of element coefficient matrix, because the sum of the elements is 0. So we have the formula C13 is equal to 0 minus into the bracket C11 plus C12. C21 is a symmetrical term with C12, so in all the matrices you will find that these terms are matching. Same is the case of C31 and C13. C31 and C13. The term C23 can be computed on the similar lines as that of C13, and C32 is a symmetrical term with C23. Thus, we can obtain the element coefficient matrices, which are very much essential in order to determine the global coefficient matrix. We can also notice the relation between the global nodes 1, 2, 3, 4 and 5, which are shown in the red color with a dark bold font. So for example, the global node number 1 is in connection with element number 1 through local node number 1. It has got no connection with element number 2, hence it is written as n. Same is the case for element number 3. Let us take one more example. So we have global node number 3, which is only connected with element number 3 via node number 2, local node number 2. Let us go back to the PPT. So the same sketch is considered over here in order to understand the procedure to find global coefficient matrix. So global coefficient matrix is made up of n into n terms, where n represents the number of global nodes. So in this case we will have total 25 terms because there are 5 nodes, 5 global nodes. Now this global coefficient matrix will consist of self terms which are arranged in a diagonal, leading diagonal, and the remaining terms are called as mutual terms because they relate to different global nodes. For example, C12, C13, C14 and so on. Now let us discuss the formation of self terms first, beginning with C11. So here we are supposed to find out the relation of global node number 1 with global node number 1 itself, and hence the term will be only C11 of element number 1 as shown over here. The corresponding term is represented over here. Let us take one more example, C22 of that global coefficient matrix. It means we have to find out relation of global node number 2 with global node number 2 itself. Now here all the 3 elements are in connection with global node number 2, and hence necessarily we'll have 3 terms contributing this self term, and the terms are C33 of element number 1, then C11 of element number 2, and C33 of element number 3. In this way we can find out all the self terms. Wherever a global node is in connection with more than one elements, those many terms, self type of terms, will appear in the formation of such self terms. Now let us discuss a typical mutual term, say C25, say C25 here. So we are supposed to find out relation between global node number 2 and global node number 5. There are 2 elements which are involved, element number 1 and element number 2, and hence the terms contributing are C32 of 1, C32 of 1 plus C12 of 2 as shown over here. Let us take one more example of a mutual term, C54. C54. So in this case there is only one element, that is element number 2, and hence the term will be C23 of 2 or C32 of 2 because they are symmetrical terms. So in this way we can find out all the self terms and mutual terms. Let us understand the presence of zeros over here. A 0 is observed in the place of C13. The reason behind this is that global node number 1 and global node number 3 are not in direct connection. There is no direct connection between global node number 1 and 3, similarly between 1 and 4. So in this way we'll have zeros present wherever the global nodes are in no connection. All these terms which are shown over here are as per these calculations using the element coefficient matrices C of 1, C of 2 and C of 3. Let us summarize. The size of the global coefficient matrix is n by n, where n represents the number of global nodes. The nodes which are not directly connected give rise to a 0 at the appropriate place in the matrix. The self terms of global coefficient matrix are made up of only self terms from element coefficient matrices. The mutual terms of global coefficient matrix are made up of only mutual terms from element coefficient matrices, and the self terms are always positive. Thank you.